Okay, now we'll take a look at a different way of representing relations and functions. And the way that we're going to look at it is using a set of ordered pairs. Okay, but before we do that, let me remind you what a relation and a function are. A relation is more general than a function. It defines relationships between inputs and outputs. The number of relationships doesn't matter. A function, however, is a relation where each input has exactly one output. Okay, so I'm going to list a relation here as a set of ordered pairs and talk you through how to think about it. Okay, so here I've given you the relation R. It's defined as follows. These braces are used for many things, but most commonly they're used to indicate a set of things. And so the things, or the elements of this set, are ordered pairs. 3, 1, 2, 5, negative 4, 2, negative 1, 0, 3, negative 4. So this set contains 5 ordered pairs. This relation contains 5 ordered pairs. Okay? Now, how is this a relation? How is this defining relationships between inputs and outputs? Well, we already know that inputs inputs are commonly represented with X and outputs are commonly represented with Y, and ordered pairs are precisely X, Y. So the first element in each of these ordered pairs are inputs, and the second element in each of these ordered pairs are outputs. Okay? So what this tells us is the input of 3 is the input 3, let's write it short. The input 3 has output 1. But we can also see that the input of 3 has an output of negative 4. So the input 3 has output 1 and negative 4. So let's say outputs 1 and negative 4. The input 2 has output, it just looks like 5. The input negative 4 has output 2. And you can see, you could go ahead and state all the relationships, but that's how a set of ordered pairs is to be described as a relation. Okay, so now we understand how this describes relationships or a relation. Now the question is R, the relation R, a function? And remember, for R to be a function, one way we could describe that, let me change the color of our text here, or does every input of R have exactly one output? Remember, this is the question you should always ask when trying to determine if a relation is a function. Okay, so we come up here and we can see that the input of 3 has an output of 1, but it also has an output of negative 4. So the answer is no. No, because at least one input has multiple outputs. Specifically, 3 has 2 outputs. Okay? So we understand relations as sets of ordered pairs now, and we can easily look at them and understand inputs and outputs and decide if the relation is a function or not based on every input having exactly one output. Now what we want to be able to do, we already understand inputs and outputs here. We might as well write the domain and the range of this relation. So we can tell that the domain, we've already stated, they're all highlighted in yellow. The domain is the set of all the inputs. So I'll use my brace to indicate a set. We don't have like an interval of numbers, right, on a number line. So we don't need an interval. We need a set of individual numbers. So the domain is all the inputs, which are 3, 2, -4, and -1. I don't need to list 3 again, I've already got it. So my domain is the set of inputs, which I've highlighted above in yellow. And I'm sure you can figure out then that the range is the set of outputs, which is 1, 5, 2, 0, -4. So now we can look at a set of ordered pairs, understand how it represents a relation, then decide if it's a function, and we can state the domain and the range given a set of ordered pairs.